Welcome to Study Loop.
This is the answer to Chapter 14, problem number 15 from the Smith Organic Chemistry textbook. And in this problem, we are asked to sketch the NMR of ethyl chloride. And so I've drawn a spectrum down here. And so I'm just going to fill it in. And what we should notice before we start is that we have two types of protons in this molecule. So we have the methyl group protons, which I've just underlined in red. And then we have these methylene protons, which I have now underlined in green. And so the methyl protons are probably going to show right around 1. And since they have two neighbors, they will be split into a triplet. So the signal will probably look something like this. So a triplet right around 1. And then the methylene protons are going to be further downfield because they are immediately adjacent to a chlorine, which is electronegative, so it will de-shield them. And their splitting pattern is going to be a quartet, since they have that methyl group as a neighbor on the other side. And those 3 protons are going to split the signal into 4 peaks by the n+1 rule. And so I'm going to put that signal right around 3, maybe a little further downfield even. So let's say 3.5. And so the splitting pattern here is going to look like this. So 1, 2, 3, 4. So there's our quartet. And then we can consider the integrations. So I'm just going to write the integration values above these in blue. And the integration values, remember, just represent how many protons each signal is representing. And so the methyl group obviously is going to integrate to 3, and the methylene group will integrate to 2. Okay, and so that's the answer here. And in order to arrive at that answer, we basically just need to apply everything that we've learned thus far in the chapter about NMR to predict where these signals are going to show, what their splitting patterns are going to be, and to what they will integrate. And so that's the answer to Chapter 14, problem number 15.